Okay, today we're going to look at solving proportions. So hopefully some of these examples we'll see today will be review, but we're going to add on to them as well. So when we're solving proportions, you definitely already know one method. The most common method for solving proportions is to cross multiply. Now, a proportion is really two fractions set equal to each other. And so if we think about a proportion that way, as in an equation, and we notice there's fractions in it, another way we can now solve a proportion is to get rid of our fractions. So multiply through by a common denominator. And this is what we were doing in our first unit this semester, as we're multiplying through. So for example, if we start out with the proportion x over 8 equals 9 over 10, then to solve it, we can start using the cross multiply method by multiplying the numbers diagonally across from each other and setting those products equal to each other. So we could start by doing 8 times 9 equals 10 times x. We then simplify 8 times 9 to 72. And let's get this to go away. And divide both sides by 10 to fully isolate your x. So if I get my pen, from here we divided both sides by 10. And so you could give the decimal version, but you know I normally prefer for you to give the improper simplified fraction. So this would reduce to 36 fifths. So x equals 36 fifths. So the method that we were using in Unit 1 was to actually multiply through. So if we look at this equation, it has the fraction denominators of 8 and 10, meaning that we could multiply through by a common denominator of 8 and 10, which is 40. And when we do that multiplication, we'll do a little bit of cross canceling here. Oh, give me the pen. There we go. So here this cancels out, so we're left with a 5 there for 5x. 40 and 10 cancel, and we're left with 4 up here times 4. Sorry, don't worry about that. So 9 times 4 is our 36. Divide both sides by 5, and we still get 36 fifths. So I just wanted to bring in that this multiply through method is a correct method for solving proportions. You're going to see that for the most part, though, when we have a proportion, I'm going to be setting up cross multiplication. Just know that you still have this method as one that you can try or fall back on as well. So let's start with our first example, practicing this. So we have 7 halves equals n plus 1 over 8. So if I'm setting up my cross multiplication, I'm going to multiply 2 times n plus 1 and 7 times 8. And these two cross products I will set equal to each other. Now what's important is that when we are multiplying 2 times this whole numerator, we should be using grouping symbols to indicate that we're doubling that whole expression. So from here, we distribute to get 2n plus 2. 7 times 8 is 56. Subtract your 2 from both sides to get 2n equals 54. Divide by 2 to get n equals 27. Now, as always, a way to check this is take your value for n, substitute it back in, and simplify and see if you get the same thing on both sides. Here we have a proportion that has 2 different expressions in the numerators. So we're going to set it up just like we did the other one, cross multiplying, and using our grouping symbols to indicate that this -4 multiplies by the entire numerator and 3 by this entire numerator. From here, we've got lots of distributing that needs to happen. And we will combine our n's and combine our numbers. So I added 4n to both sides. Then I brought the -3 to the right, so I undid the subtraction and added it, which gave me -5. Divide both sides by 10, which reduces to n equals -1/2. Here's another one. So when we set up the cross multiplication here, we'll do x times x and 5 times 20 and set that equal to each other. So x times x, if you'll remember, multiplying variables, we add their exponents, so this becomes an x squared equal to 100. Woo! Okay, to isolate an x squared, this To do that, we'll take the square root of it. So we need to take the square root of both sides. And the square root of 100 is 10, so x's value is 10. So that means I could put 10 in here and 10 in there, and notice that they both reduce to the same fraction. Okay, so let's move on to proportion word problems. When we are solving proportion word problems, it's important to set our proportion up first. So that's like your set up your equation step. It's also incredibly important to keep the units the same across the numerators and keep the units the same across the denominators. If you do that correctly, it is very likely that your equation is correct. And then cross multiply to solve. Okay, so here's our first word problem. Susie is training for a hot dog eating contest. She ate 6 hot dogs in 45 seconds. If she eats at the same rate, how many seconds will it take for her to eat 25 hot dogs? I want you to notice in this problem that 6 hot dogs and 45 seconds go together. So because they go together, they will actually stack on top of each other in a fraction. And wherever I put the hot dogs, if I put it on top or on bottom, that part doesn't matter as much. What will matter is where I put, is that I align hot dogs in the same place on the other place of my fraction. So here's what I'm talking about. If I chose to put 6 over 45, then I'm choosing to place hot dogs on top of seconds. So that means if I'm wondering how many seconds it will take for 25 hot dogs, well, I'd had hot dogs on top, so that's where I'll keep my 25, and I put my variable for the number of seconds that many hot dogs will take in the denominator. So it may help for you to actually just put 6 hot dogs and seconds, like a little units right in the problem so that you can clearly see hot dogs is across the top and seconds stays across the bottom. From there we cross multiply, so 45 times 25 is 1,125 and 6 times x is 6x. Divide both sides by 6 and simplify. So you could use a calculator to simplify this. Now, as I've said, often I like for you guys to leave your answers in improper simplified fraction. However, in a word problem situation, if you know the units you're looking for, you need to make sure your number actually makes sense with units. So if you think about seconds, it wouldn't make sense to say it took 1,125 seconds, right? So we're going to actually use a decimal answer here because we count seconds in decimals. So that's why I did convert that one to a decimal. So it will take quite a bit longer for 25 hot dogs. All right, here's our next example. I have 89 pages of a book left to read. It usually takes about 30 minutes to read 45 pages. There's all your units you're going to need. How much time should I allow to finish my book? So this is how many pages are left to read. And we know 30 minutes, we can read 45 pages. So right now, go ahead and decide where you're going to put your pages, up top or bottom, and where you'll put minutes. And set up your proportion, and we'll check together in a moment. So I set mine up with pages up top. If you chose to set yours up with minutes up top, that is completely fine. Yours would look like this. And we will all get the same thing when we solve here. So it does not matter as long as your units stayed the same across. So this is where you might want P's right here and M's right here just to confirm that you did line up your units. All right, we cross multiply. 89 times 30 was 2,670, and I'll divide both sides by 45. Simplify to get 59 1/3. Now the reason I went to, let's see, how much time should it take? So this is, I should have minutes here. And you can convert this one to decimal, like we were saying, minutes and seconds go to decimal. So this would be 59 minutes and 20 seconds because 1/3 of a minute is 20 seconds. So that also would have been an acceptable answer. But I will not require you to do this 20 seconds portion, okay? If you leave it like this with minutes at the end, as long as you got it to a mixed number so we can see it's almost a full hour, that's what's key here. Okay, we're going to talk about a new kind of proportion word problem, and it's called direct and indirect variation. So with problems like this, proportion word problems, if you notice that you're being told that your variables are directly proportional or they vary directly, then you're going to set up a proportion where the first x is over the second and the first y is over the second y. So kind of keeping the units in the same place and keeping the first with the first, second with the second. If it's indirect, you'll notice there's a slight switch. We still start with first x on top, second x on bottom. However, in the second portion of the proportion, we'll flip the order to have the second y actually on top and the first y actually on bottom. So this is also referred to as inversely proportional. So if you notice that you're being told in the word problem that these two, whatever they may be, are inversely proportional, I would recommend setting up this structure first and then going from there to fill in the missing parts and solve. So let's take a look at this. So here we are. Heather's weekly pay is directly proportional to the number of hours she works at the record store. So I want to stop right there because the order you read this in is actually really key to knowing how to set up the proportion. So if we see Heather's weekly pay is directly proportional, so we'll use the x1 over x2 equals y1 over y2 structure. So this is something you'll just have to learn. So the weekly pay is directly proportional to the number of hours. When you're reading this, the first variable or first variable that you read or unit is your x. After the directly proportional, this unit becomes the y. So then if we continue reading, we read that her pay is $174. So pay is x, so that's my x1. Let's see if I can fit it. For 24 hours. Well, 24 hours goes with the x1, so it's our y1. We're wondering how much, or find the amount of pay for 40 hours. Hours is a y, so that means 40 is your y2. So it's really important that you clearly label x1, y1, x2, y2 in the actual word problem so that from here all we have to do is fill in these numbers to our proportion structure for directly proportional. So we know we're following this format. So x1 was 174. Y1 was 24. So notice with direct and indirect variation proportion problems, the units actually stay the same vertically instead of horizontally. And you'll know this because it will tell you directly or indirectly in the problem. So that's your little flag, that, little red flag, I got to follow this structure instead. From here, cross multiply, okay? Simplify and solve for x. So dividing both sides by 24 here. And simplifying. So we get x, which stood for pay, $290. Okay, so that's a directly proportional problem. Let's look at another one. The volume, V, of a gas varies inversely as the pressure P on it. So right there in that first sentence, we're told our variables and we're told which structure to use. We're told varies inversely. This is similar to indirect variation. So V came first, or volume came first, so that's our x variable. Pressure came second, that's our y. And varies inversely means we still do x1 over x2 equals, but now y2 over y1, these flipped, remember? Okay, so if the volume is 240, that means that's your x. under pressure of 30 kilograms per centimeter squared, okay, that's your y, then what pressure has to be applied to have a volume of 160? So this is our second x, because it's our second volume one, and this was y1. So we're looking for y2. So this time the variable will go up top. Now the units really aren't important until the very end, but we're putting x1 is 240 over x2 is 160 equal to y2, we don't know, over y1 right here, 30 in the denominator. Cross multiply, simplify, and isolate. And we get y to be 45, and y stood for pressure. And if I look at over here, it said pressure was kilograms per centimeter squared. So I'm just going to finish by writing kilograms per centimeter squared. It really doesn't matter if you understand what this means, kilograms per centimeter squared. It is okay if you don't know what that is, as long as you knew how to get there. Okay, at the end, just copy whatever units are given to you. Oops, too many. Okay, and one last one. The amount of money spent at the gas station varies directly with the number of gallons purchased. So right there, we are told the amount of money is first. So money is x. Varies directly means the normal structure with y1 on top with the number of gallons, y, purchased. So if we read the next portion, we can find x1 and y1. If 11.5 gallons, so notice it gave us gallons first. So that's your y1 was purchased for the cost of $37.72. That's x1. You have to pay attention to the units because this time it gives it to you in a slightly different order. Then determine the number of gallons purchased if the cost, money is x, so this is x2, was $65.60. So filling this in, we know we're using the varies directly proportion setup. And x1 should be our price of $37.72. And x2 is the other price of $65.60, with y1 being 11.5 gallons. From here, cross multiply, simplify, and divide both sides by your $37.72 to isolate to get y to be 20. And y's variable was gallons, so this should be 20 gallons. So from here, we have now reviewed how to solve proportions and how to set up special kinds of proportion word problems. So the more basic ones, so ones that do not have varies directly or indirectly, you'll just set up with units the same across the top and across the bottom. If it specifically says varies directly or varies indirectly, you will memorize these two formulas so you know which of the two to set up. And that's it for this lesson. All right.